beautiful day it is today. Look at that sun that's so far away that is not there right now.
Well, Marcus, according to my calculations, the sun seems to be, the sun is 1 out of 200 billion stars in our Milky Way. That is Juan. Juan, huh? Yeah, 1 billion stars. Okay, whatever. But the star is the closest one to the Earth. This ball is the sun. This rock is the Earth. That's a big old star compared to the Earth. And the Earth's huge and we're small. So the sun's just humongous. But besides the fact, do you know how far the sun is from the Earth?
No. How far?
It is 960,000 miles away from Earth. That's how far away the sun is from the Earth. And it's just one star. You imagine if we had those 2 billion stars around Earth, we'd all melt, die, be dead, never lived, existed.
So you're trying to tell me that this ball, which is bigger than that rock, is the sun, and that's the Earth.
Yeah.
Then how come when I look in the sky, the sun is so small? Can you explain that?
Because the distance between the sun and the Earth is 292,960,000 miles away from Earth. So at a distance, at a ratio like that, this big old sun looks teeny tiny to us. It looks like this. But it's not really like this. It's more like this compared to this.
Okay.
Sun and Earth.
That makes sense. Mm-hmm. So, see, because the sun is made up of gases, you see, there's no sharp boundaries between its various layers.
So you're saying out of the 4 layers, the solar interior, the visible surface or photosphere, and the 2 atmosphere layers, the chromosphere and the corona?
Correct. The chromosphere, the first layer of the solar atmosphere, found directly above the photosphere, as you mentioned earlier, relatively thin, hot layer of incandescent gases. I don't know what that means, but I'm gonna find that out soon.
You might want to Google it. Maybe Bing.
Bing is better than Google, kids. Make sure you know. Okay. Few thousand kilometers thick, you see. Its top contains numerous spicules, which are the little narrow jets of rising material. Spicules, do you know what that is?
No, what's a spicule?
Well, when people draw the sun, you know how they always do that little triangular border thingy around that?
Oh, you mean like the little flame?
The flames.
Mm-hmm.
That's pretty much what a spicule is.
So why did they name it spiculo? Why can't they say the little flame?
I don't know. It's science. Makes no sense to me.
Nerds. Did you know that the corona is the outer layer? It's a weak layer of the solar atmosphere.
I didn't know that, actually. No.
Did you know that? The temperature at the top of the corona exceeds 100 million K. Did you know that?
No, but that sounds like an amazing barbecue if it exceeds that temperature.
Well, we gonna learn today.
Yes,
we gonna learn today.
But, adding on to what you said, did you know the photosphere is the region of the sun that radiates energy to space, or the visible surface of the sun? The photosphere is what we look up and see.
If there was a sun, like there's no
if there was a sun today, but there's not. It consists of layers of incandescent gases but less than 500 kilometers thick.
I got a question.
Yeah?
Does the photosphere take photos?
No, it doesn't.
Is that where we got photography from?
I have no clue.
Oh, okay.
Does that answer your question?
I guess.
Okay. Where were we? It exhibits a grainy texture made of many small stuff called stuff. We're gonna leave it at stuff. We just know it's there. Produced by convection currents, and that stuff actually happens to be granules in the photosphere.
Granules.
its temperature is approximately 6,000 degrees Kelvin, which is about 10,000 or so degrees Fahrenheit.
Interesting. You know when you look at pictures of the sun, or sometimes you look at the sun and you see like little dark spots on there?
Yeah.
What are those? Is it like sun cancer? Like, can the sun give itself cancer?
No. The sun can't give itself cancer. Those dark spots on the sun is a sunspot, which, because in that spot of the sun, it's cooler than the rest of the parts around it. So that's why we get those sunspots.
Ah.
And did you know, prominences on the sun are a cloud-like structure that have chromospheric gases, and they are ionized gases trapped by magnetic fields, so it can't really touch the Earth. It looks like a little wave.
But how are they magnets if they're gases?
Well, that part, that's gravity holding it in. Gravity holds in the sun together so the sun won't explode, and then the sun has all this energy which keeps it from collapsing on itself.
Oh, alright. Yo, Marcus, do you know what solar flares are?
I believe that's a Dragon Ball Z power that, if I'm correct, that Goku does?
I'm not sure. It could be Goku. I'm thinking it could be Piccolo, the green pickle looking thing. But okay, whatever. Solar flares are not that. You're way off.
Oh.
Solar flares are like self-made fireworks from the sun. There's self-flares. You know what flares are? The ones that go up and...
Yeah, I know what
the sun makes them by itself because it has so much energy that a low ball of energy mounts up and it just explodes. And it's pa pa, and it's cell phone flares. And they explode because the flares have ultraviolet, radio, and X-ray radiation in them. And that energy mounts up until the sun or that little spot can't hold it, and that's how flares are formed. That's how you see the little like flames popping out of the sun.
Okay. Well, did you know an aurora is the aftermath of one of those solar flares you said earlier? It's a bright display of ever-changing light. It goes from like red to blue to green, blah blah blah. And
Marcus, why is it so hot?
well, man, that's because the sun is so hot because of nuclear fusion, man. All the energy in the sun, built up energy over what, like 10 billion years. It's gonna get pretty hot, man. It's gonna get hot.
I say we should cool off. Let's go for a swim.
Let's go for a swim. Man, what a beautiful day it is today. Look at that sun. That is so far away. That is not there right now.
So yeah, you can blooper out the middle part. Alright, did you start?
Yeah, he started.
Flares.
Isn't that some Dragon Ball Z power that I think...
Quit. Fell. Okay, let's go.